So the third technique is what I call simplifying. It doesn't have to be a complex fraction. So a lot of times it's a complex fraction, but really just simplifying is the main technique here. In case you're not sure what a complex fraction is a fraction of fractions, a fraction involving fractions. So if you look at this guy right here, this is an example of a complex fraction. We have a fraction, but then in the numerator, we have more fractions. So this is like a fraction involving fractions. Okay. And I guess, again, this is a little bit of algebra review, but if you have something like some expression A divided by B, this is going to be the same thing as saying 1 over B times A. These two things mean the same thing. So I'm going to use that to simplify my example 5. When I look at my example 5, the first thing I'm going to do is I'm going to write this as the limit as x goes to 1. I'm going to put the 1 over x out in front like this, 1 over x minus 1 in front like this, and then I'm going to put 1 over x plus 1 minus 1/2 like that. So I'm saying my b is the 1 over x, the b is the x minus 1. So I just write this as 1 over x minus 1, and then I just rewrite the top there. So how do you think about this? Dividing by 2 is the same thing as multiplying by 1/2, right? They mean the same thing. This just makes my writing a little bit easier. Okay. Now, simplifying is trying to write this as a single expression. So from my experience, a lot of students don't love working with fractions. If I want to subtract 2 fractions, do you guys know what the first thing I need to do is? Any thoughts? Well, when you want to simplify, that's right, Cynthia, you need a common denominator. So in this particular case, we're going to have this. Our common denominator is going to be the product of the 2. So we're going to have 2 times x plus 1 minus 2 times x plus 1 like that. And you got to ask yourself, how did you get this denominator of 2 times x plus 1? You have to multiply top and bottom by 2. So then this guy here becomes a 2. So I hope you can see if I simplify the 2's, I get the original thing back here. How do I achieve this denominator? I multiply top and bottom by x plus 1. So because I multiplied the bottom by x plus 1, I have to multiply the top by x plus 1 too. So you get an x plus 1 like this. So this is rewriting the expression with a common denominator. Okay. Once I have that common denominator, I can write like this. I write as x goes to 1. Write this as 1 over x minus 1. And then I can put my common denominator like this. So this is 2 times x plus 1 like this. And this is going to be 2 minus x plus 1. So I'm going to highlight this negative and these parentheses here. From my experience, the way that students mess this thing up is they forget to distribute the negative. So I'm going to make a comment here. Don't forget parentheses. And when I want to say, don't forget to distribute. Okay. So now when I look at this guy, this is the limit as x goes to 1, 1 over x minus 1. when I simplify this, this is going to be 2 minus x minus 2, sorry, minus 1, all divided by 2 times x plus 1. And how does this simplify? This simplifies as the limit as x goes to 1, 1 over x minus 1. You're going to have 2 minus 1 is 1, so this is 1 minus x over 2 times x plus 1. So what do you notice about this one and this one? Can you guys see that these are exact opposites of each other? So I can really factor a -1 out of the numerator. So this is going to become the limit as x goes to 1. I could factor out a -1 from the numerator, and that's going to make that guy x minus 1. And then I'll have a x minus 1, and then a 2 times x plus 1. So I'm going to highlight these guys. These guys are opposites. You can factor out -1. Now I got my 0 factor in the denominator finally canceling out. So we're just going to get a -1 in the numerator and 2 times x plus 1 in the denominator. So this is going to give us a -1/4 when I do the direct substitution property. So let's highlight this guy. And this is the example 5. All right. Is there any questions about this one? This section has a lot of algebra. So if your algebra is weak, you're going to need practice for sure. All right. So we're not going to, I don't have a simplifying a complex fraction here. I have but you can use the simplify technique to do number 3. So why don't you guys try number 3 real quick and all right. So why don't you type your answer in the chat box? And then I'm going to do the 3, 2, 1, go thing. Ready? 3, 2, 1, go. All right. All right. I'm assuming the answer is -10. Let's do it if we're not sure. So you'll see I wrote a couple formulas here in the red, continuing in our little just-in-time pre-calculus review. When you have an expression, a quantity squared, this happens so much that a lot of times people just remember how to calculate it. And you could FOIL this out like I did over here. You could FOIL it out with the A here and a B here. But like I said, this happens so often, people just remember the pattern. So I'm going to use that pattern to solve this question. So we're going to get the limit as h goes to 0. When I distribute this first term over here, this is going to give me -5 squared, which is 25. Plus 2 times -5 times h, so that's going to be minus 10h plus h squared minus 25, all divided by h. Okay. So once I've distributed, I hope you guys can see that we'll have a 25 in front and a minus 25 behind there. And then now what's good is that the remaining terms in the numerator have h. So I could just factor out a h from the numerator. I'm going to get the limit as h goes to 0. I could pull out a h and I'm going to get -10 plus h. On the denominator, I'm going to have an h over here. So then those h's from the numerator and the denominator cancel. So this is what I want, right? Because I have a 0 factor in the denominator. So in fact, I should have checked the direct substitution to see I got 0 over 0. Let's pretend I did that. And then, and now I get this nice expression here. So now I can just plug in a 0 in for h, and I'm going to get -10. Does that make sense to everybody? Does anyone have any questions about this? All right, cool. So,
Wait, so can I see it again?
yep. Did you have a question about this?
Is this just mainly, is this on the substitution, right?
This is simplifying. So I distribute this guy to get this expression right here. And then once I simplified that, I see I can cancel the 25s. And now after I've canceled 25s, I have a common factor of h. So I can factor that common factor of h out times -10 plus h. And then you could cancel the h's. So you just end up with -10 plus h. And now I substitute at the last step because I have no 0 in the denominator. So I can just plug it in. Direct substitution property at the end. Does that make sense?
Yeah. So one thing I noticed is, are we always trying to like make it so that we can cancel out the variable?
Well, you're trying to cancel the 0 factor in the denominator. So for the number 1, the 0 factor is x minus 5. So after I factor, I cancel out the x minus 5. For number 4, the 0 factor is h. So I'm trying to cancel out the h. For number 3, the 0 factor is h. So I'm trying to cancel out the h. So for all these examples on the first page here, we're trying to cancel out whatever the 0 factor is on the denominator.